It opens its eyes. It smiles. It says, "That was interesting." It says, "That was interesting." Here's the question that should make you uncomfortable. Did you just travel, or did you just die? Because physics, if taken seriously, really seriously, suggests something deeply unsettling. Teleportation in the way people imagine it doesn't move you. It replaces you. And to understand why that matters, we have to start somewhere much more ordinary than science fiction. We have to start with something that feels so simple you've never questioned it. What it means to be you from one moment to the next. Right now, you feel continuous. You feel like the same person you were 5 seconds ago. Your thoughts are flowing. There's no break, no flicker. But biologically, that's already strange. The atoms in your body are constantly being exchanged. The air you breathe becomes part of you. The carbon you exhale leaves you. Over years, most of the atoms in your body are replaced. Yet you insist, correctly, that you are still you. So apparently you are not defined by specific atoms. You're defined by something else. Pattern, structure, arrangement. If I take a pile of Lego bricks and build a castle, the castle isn't in the plastic, it's in the pattern. Break it apart, rebuild the same pattern with new bricks, and we'd say it's the same design. Now here's the twist. Physics agrees. At a deep level, what matters is configuration, how particles are arranged, how energy is distributed, how information is encoded. So you might think teleportation is just extreme rearrangement. Scan the pattern here, rebuild the pattern there, no problem. But physics has a few rules that complicate this fantasy in ways that are not negotiable. Let's rewind. For centuries, scientists thought matter was simple, solid, continuous, little billiard balls bouncing around. If that were true, teleportation would merely be an engineering challenge. Measure positions and velocities, recreate them somewhere else. But then quantum mechanics arrived, and it did not politely adjust the story. It detonated it. At the microscopic level, particles do not have definite positions and velocities simultaneously. There is a fundamental limit encoded in what we call the uncertainty principle, not because our instruments are clumsy, but because nature herself refuses to define both properties at once with infinite precision. This is not a technological problem. It's built into the structure of reality. Imagine trying to make a perfect copy of a page in a book, but the ink rearranges itself the moment you look too closely. That's closer to the quantum world. And there's an even sharper rule, the no-cloning theorem. In quantum mechanics, it is impossible to create an exact copy of an arbitrary, unknown quantum state. Not difficult, impossible. This isn't philosophical, it's mathematical. It falls directly out of the linear structure of quantum theory. If you could perfectly clone unknown quantum states, you would violate the fundamental consistency of the theory. So now we face a problem. You are made of quantum states. Your brain is a vast, dancing network of quantum systems. Every neuron, every protein, every ion channel is governed by quantum laws at its core. If teleportation requires copying your exact physical state, quantum mechanics says you cannot copy it. But there is a loophole, an interesting one. Quantum teleportation actually exists. Physicists have done it in laboratories. Photons have been teleported across cities. Quantum states have been transferred between particles without physically sending the particle itself, but the process reveals something crucial. Quantum teleportation does not copy the original state, it destroys it. The original particle state is irreversibly altered during the measurement process. The information appears elsewhere, but the original is gone. So even in real quantum teleportation, nature insists on a sacrifice. Information moves. Identity does not survive duplication. Now let's make this personal. Suppose your body is scanned with perfect quantum precision. Every particle's state is entangled, measured, encoded. To do that measurement, the original quantum state must be disturbed, collapsed in everyday language. The act of extracting the information changes it irreversibly. Then the information is sent elsewhere. A new body is constructed atom by atom, state by state, matching the extracted data. That new body wakes up and insists it is you. And from every external perspective, it is indistinguishable from you. Same memories, same personality, same scars. But the original body, during scanning, was physically dismantled. The continuity of its physical processes ended. From the inside, that's death. Now here's where people push back. But wait, they say. If the pattern is preserved, why does continuity matter? Good question. Let's examine it carefully. Imagine instead of teleporting, I build a perfect duplicate of you right here, without destroying you. Now there are two of you. Both claim to be the original. Both remember stepping into the machine. Both feel authentic. Which one is you? You cannot be both, because your subjective experience cannot split into two streams simultaneously. You cannot experience two separate futures at once. This reveals something subtle. Identity is not just pattern, it's continuous causal flow. Your brain is not a static structure, it's a process. Billions of neurons exchanging signals in a delicate, ongoing chain. Each moment grows out of the previous one, like a flame passing from one instant to the next. Teleportation interrupts that flame. It extinguishes it here. It ignites a new, identical flame elsewhere. From the outside, no difference. From the inside, everything. Think of it like this. Imagine you are reading a book. Page after page, the story unfolds. Now suppose someone burns the book halfway through and prints a perfect copy from a digital file, continuing the story exactly where it left off. The narrative continues seamlessly on paper, but the original physical book was destroyed. In teleportation, the reader inside the book, the conscious process, does not jump from ashes to ink. It simply ends. We can dig deeper. Physics tells us that information is physical. It is stored in matter, carried by energy, encoded in quantum states. And information has strict conservation laws. You cannot copy unknown quantum information. You cannot extract it without altering the system. So teleportation must either destroy the original to transfer the state, or create duplicates, which violates quantum mechanics. There is no third option. Now let's consider a comforting objection. But aren't I already changing all the time? My atoms are replaced. My brain cells modify connections. Isn't that like teleportation happening gradually? This is where continuity becomes crucial. The difference between gradual change and abrupt reconstruction is like the difference between a river flowing and a river being replaced by a perfectly shaped block of ice. Both may have identical shapes, but only one contains motion. Consciousness appears to depend on uninterrupted physical process. Neurons fire, electrical signals propagate, chemical gradients shift. These events form a continuous chain of cause and effect. If that chain is severed, even for a millisecond, and replaced by a replica that merely resembles the previous state, the original causal process is gone. We don't fully understand consciousness, let's be honest about that. But every neuroscientific insight points toward it being an emergent property of dynamic activity, not a static snapshot. A frozen brain is not conscious, even if structurally intact. A scanned and reconstructed brain, no matter how accurate, would begin a new process. And that distinction matters because subjective experience is tied to the persistence of that specific physical process. Now here's another angle. In thermodynamics, entropy measures disorder, but more precisely, it measures how many microscopic configurations correspond to a macroscopic state. Living organisms maintain low entropy locally by constantly exchanging energy with their environment. You are a self-sustaining thermodynamic process. Teleportation would require stopping that process entirely, disassembling the molecular machinery, halting metabolism, ending electrical activity. The moment that happens, the thermodynamic arrow of time for that organism ends. The reconstructed version may start a similar arrow, but it is not the same arrow. Physics does not recognize mystical continuity. It recognizes causal chains. If the chain breaks, the system ends. Now let's revisit quantum teleportation experiments. When scientists entangle particles and transfer quantum states across space, they confirm something profound. Information can move without matter moving. But the protocol requires classical communication as well. You cannot teleport faster than light. Einstein's speed limit remains intact. Even at the quantum level, teleportation is not magical transportation. It's coordinated state reconstruction under strict conservation laws. And always, the original state is destroyed in the act. So science fiction's transporter beam, which scans you, disintegrates you, and reassembles you elsewhere, is not transportation. It's a method of suicide followed by high-precision cloning. The clone doesn't know. It feels continuous. It believes it survived. But belief is not continuity. Let me ask you something unsettling. If tomorrow a machine created a perfect duplicate of you while you remained intact, would you volunteer to be destroyed so the duplicate could continue your life? Most people hesitate. That hesitation reveals intuition, grasping something physics already implies. Identity is not mere information, it is ongoing physical existence. Now, could there be a loophole? Some philosophers argue for pattern identity. They claim that if the pattern persists, that's enough. From a third-person perspective, maybe. Society would treat the duplicate as you, legally, socially, functionally. But physics is not about social convenience. It is about physical processes. And physical processes cannot jump discontinuously across space without preserving the causal chain. There is no known mechanism in modern physics that allows your conscious process to detach from one brain and attach to another identical one without interruption. Even quantum entanglement does not permit that. Entanglement creates correlations, not identity transfer. So where does this leave teleportation? As a technological marvel, perhaps achievable in limited forms, teleporting quantum states of small systems. But as a method for human travel, it carries a brutal implication. It does not move you, it replaces you. Now I want to slow down here because this is not just a technical claim. It forces us to examine what we mean by survival. If your memories, personality, and relationships continue in a duplicate, is that enough? Or is there something about this specific stream of awareness, this particular unfolding, that cannot be replaced? Physics does not answer the philosophical question of what matters, but it does clarify what happens physically. The original process stops. A new one begins. They are not numerically identical, even if structurally identical. And here's the final twist. From the outside, teleportation would appear flawless. No one could tell the difference. Your friends would hug you. Your family would celebrate. The duplicate would swear continuity. Only you, the original, would never know what happened because you would be gone. The universe would continue. The pattern would continue. The story would continue. But the specific chain of atoms and electrical pulses that is you right now would have ended. Physics, with all its equations and experiments and quantum mysteries, leads us to an oddly human conclusion. Survival is not about resemblance. It is about continuity. And continuity, once broken, cannot be restored by copying. So the next time someone casually says, "I'd love to teleport to Paris," you might smile and ask, which version of you is arriving? Because the deeper we look into matter, into quantum law, into thermodynamics and information theory, the more we discover that nature is not sentimental about identity. It preserves information under strict rules. It preserves causal structure. But it does not guarantee that a pattern reconstructed elsewhere is the same physical existence. Teleportation doesn't move you through space. It ends you here and starts someone else there. And that is not a failure of engineering. It is a consequence of the laws of physics themselves, which makes the universe once again far stranger and far more precise than our science fiction dreams.